Hello, everybody. Welcome to this new Malt Academy. Before I start to explain to you what's going to happen today, can you please confirm in the chat part that you can actually hear me and see me? And maybe, Guillaume, same for you, if you can speak a little so we can try.
Hello, everyone. Pleased to be here with you today.
Can you hear Guillaume as well? Okay, it seems fine. Great.
Perfect.
Thank you very much, everybody. So today it's Guillaume who is going to give a Malt Academy. But before I let you the mic, Guillaume, and I let you present yourself, just a very quick introduction. So I am Camille Blanc. I work at Malt, who is organizing this Malt Academy. As a reminder, Malt is a platform that makes contact between freelancers in France, Germany, and Spain, and soon in Belgium and Netherlands. Between those freelancers and companies. So any kind of companies, it can be huge companies as well as startups. And we have launched the Malt Academies more than 1 year ago at the very, very beginning of the first lockdown in France because we wanted to help freelancers keep on learning between lockdown and keep on also, exchanging with each other. So we've been doing this for more than a year. Honestly, it's been a great success and we are very happy to do it. And we are especially very happy to have speakers like Guillaume, who are experts in their domain and who can share with you a great and valuable content. So I think that's all for my part. If you have any questions on Malt Academy or Malt, I will be back at the very end of this workshop, this webinar. So do not hesitate. Also, just before I leave you, if you have any questions, please try to put them as much as possible in the questions tab so that it's much easier for Guillaume and I to choose them and to ask them live. And voila, that's all for me. I give you the mic, Guillaume. Thank you again for being here today.
Thank you so much. So let me share my screen here. All right, so hello again, everybody. Today, that's my pleasure to tell you all about choreography versus orchestration in serverless microservices. So I usually do this presentation with my colleague Mete, who's based in London, but this time I am alone on stage to tell you about this topic. So I'm Guillaume Laforge. I'm a developer advocate, a cloud developer advocate for Google Cloud. I focus mostly on the serverless technologies, the various products and services that you can use for developing, deploying, orchestrating, managing, etc., microservices in a serverless fashion. Perhaps some of you may know me for the creation of the Apache Groovy programming language. I was one of the co-founders. And also, perhaps you listen to my voice, but in French, for the French-speaking among you, in the Les Castcodeurs podcast, perhaps. So that's about it. So we're going to speak about choreography and orchestration, but we're not going to speak about that choreography and that orchestration, right? It's not ballet dancing or orchestra concerts and such, but instead how to orchestrate and make microservices work together, basically. And there are two ways or a few ways to make that happen. So let's think about a use case for a second. Let's say you've got a kind of shopping application that you've already split into different microservices. So it's not a big monolith. You've already done the effort of splitting it, if it makes sense. It doesn't mean that you have always to split big monolith. I mean, split the monolith when it makes sense, when you feel the need for that. So here in this example, I have a front-end web application that is going to call some payment processor. Once the payment is done, perhaps we're going to call the shipper service that is going to prepare the order and ship that to the customer. And then a notifier service that would notify the customer that it's going to be shipped to their homes. Or potentially, if there's a problem in the payment processing or shipping, perhaps it's going to notify your on-call team or something like this. So I think I explained this after. Yeah, I'll go through the pros and cons. So if you do something like this, there are pros and cons. It's usually better than a single monolith because you can split the responsibility across different teams that focus on one particular area or business concern in your application. So that's interesting. Also, potentially with microservices, you can say, okay, this one, for example, the front end or perhaps the payment processing is going to be used more than notifications or shipping, or there are always differences in terms of traffic for one particular service or another. So you could scale them independently on different kind of hardware or solutions with different concurrency levels, etc. So that's good. It's usually easy to implement because here in this example, services call each other one after another. But on the other hand, it's not great because there's tight coupling between the various services. So you run the risk that one particular service would be a single point of failure and would fail the overall business transaction or business process. I mean, another approach would be that the front end calls each and every service. So as if the front end is used as an orchestrator. That's also another approach, which is closer to what we're going to explain with the orchestration approach. But well, there are pros and cons to each anyway. Also, if you think about things like error reporting, retry, and timeout logic, so if your service failed, when are you going to retry and how much time and how long will you wait before retrying? So you'd have to handle that logic either at the front-end level or within each service. So each service would have to know quite a bit about the others. So you would have some code here and there, some spaghetti code to handle how to properly call the other services. And in the end, who really ensures that the whole transaction is successful? So if it's chained calls, there's not really one service that would be responsible for saying, okay, it worked, or we have to, come back to square one and redo the whole thing, or notify if something failed in the previous steps, etc. So it's potentially a bit more complicated if you do it this way. In a choreography event-driven approach, so instead of having each service call each other directly, here you're going to use some kind of message broker, like on the Google Cloud, you can use something like Cloud PubSub. You have topics, you can exchange messages on those topics. So the front end could send the order request as a kind of message on the broker. Then the payment processor might pick up this message on the topic. Then it could send another message that will be picked up by the shipper service, etc. So there's an exchange of messages. And at the end, perhaps you might notice that, okay, there was no notification or no shipping. So you could do some logic. Perhaps another service would do that to check that all the messages happened and collect everything to ensure that, okay, the business transaction actually worked. So this is another approach. Again, in the simple case, that's okay. But in a more complex kind of transaction with really tons of services and also third-party APIs, it can become more complicated. So let's have a look at this flow chart where you would have an inventory system that you have to call into to know if what you want to order or ship is available. So is it out of stock or not? Then you might request the supplier, a supplier API to order back some products so that they are back in the inventory and back in stock. Also update the inventory order database. You might use a third-party service to send notifications, for example, notifying the customer with the send grid. Or if orders are big orders, perhaps you want to notify the Slack channel of your sales rep. So messages through PubSub topics are it's a great way to really decouple the services, but on the other hand, it's hard to really know which kind of path you went through in such a kind of flowchart to really know what went well. If it's really a chain of services, that's fairly straightforward, but for more complex cases where you have tons of events flowing through the system, it might be more complicated. So pros and cons, that's great. Services are loosely coupled. That's easier for changing them, updating them, scaling them more independently. There's no single point of failure, well, except potentially the message broker. If it failed, of course, nothing's going to take place. Events are really great for whenever you need to extend the system. If you need to add new events, that's a new kind of message or new topic. As well as if you want to add a new service, it's going to be, well, just a service that's going to listen to existing events or to existing topics. So it's very easy to continue developing and adding new services. But perhaps you might lose the actual vision of the overall process, because there's not like a flow chart somewhere that explains everything, or you'd have to be good at properly documenting things. In terms of the cons, it might be indeed more difficult to monitor the whole system, because you might wonder, okay, did I see that message passing in the message broker or not? What happened? Or potentially, when something fails, for example, you might be seeing one instance of a particular service that fails. You see some errors in the logs. But then how do you correlate this failure with the rest of the process not going on? Or you might see different failures of different services, but are they actually related or not? It becomes quite complicated to properly understand what went wrong in the system. And yeah, I forgot to mention, I have a little case study at the end of the presentation. And this feedback, the pros and cons of the different approaches, it's something that my colleague and I learned the hard way, in the sense that while we were developing our project, we faced those problems and concerns, etc. So let's continue on the cons. The business flow is not captured explicitly, in the sense that, well, you don't have a flow chart that explains everything, where things are going. When you've got a complicated diagram, well, complicated flow, it would be nice, or especially when new members join the team, how to explain to them what happens, what service is going to call which other services through which messages or topics. You have to be good at documentation for that, or use an orchestrator, but we'll come back to that. Yeah, error retries, timeouts are still hard to do. Depends sometimes. If you use something like PubSub, you can define retry logic and timeouts at the configuration level of the topics, for example. But yeah, there's not a global way of defining this for each and every process. For example, potentially different business processes may have different needs or requirements for the error retries and timeout. And again, yeah, who ensures that the whole transaction is successful? You also have to be good at monitoring and observability to fully understand what's going on, especially when a business process goes wrong. With an orchestration approach, this time we're going to actually have another service, an orchestrator that's going to monitor the whole flow, and that's going to invoke the services and ensure that things go right or wrong, and also handle retry policies, etc., in a single place. There are, again, pros and cons, of course. So what's great is that if you use some kind of tool that orchestrates the calls, the invocations of those services, the business flow can be captured more centrally. So I'm going to show you Google Cloud Workflows as an example of this later on. With that kind of products, but that's true with the competing products as well, of course. I'll mention a bit of the landscape and the other products, but I'm not a specialist on the other products, but I'll tell you about them anyway. So when you use such orchestrators, what's great is that the business flow is captured centrally, in the sense that you have a diagram, you have some kind of configuration file that defines what those business flows are. And since it's usually in the form of some kind of textual representation, you can also version that textual format or configuration language into Git, for example. Each step can be monitored depending on how you write your business workflow definition file. At the level of this definition of file, your workflow definition can say, okay, for this particular service, I want to retry up to 5 times, or I want to wait up to an hour, or 5 minutes, and have different policies for different services, or different policies for different business processes. Usually, orchestrators work with REST interfaces. So instead of using pub/sub messages, for example, those orchestrators usually use REST API. So your microservice would expose a REST API. So you don't necessarily need for events. And the other benefits, just like a loosely coupled event-driven approach, services are still independent of each other and don't have to know about the existence of each other. In terms of cons, just like with a message broker, potentially the orchestrator becomes the single point of failure. Normally, unfortunately, when you're using an orchestrator from a cloud provider, whether it's Google Cloud or someone else, we are responsible for ensuring that we have a high level of SLA that is available for that service. So normally, it shouldn't be down much, if at all. Also, if you develop your services with an eventing approach, perhaps you were not using REST, or you might have to convert things in order to use REST or expose a REST interface. Oh, something I forgot about the in the pros, perhaps I should add that at some point. It's the fact that if one of your microservices has a certain level of SLA, if you apply at the workflow definition level that you want to do retries and timeouts with a special policy for a particular service, you can artificially increase the SLA of the underlying service, because you can retry and perhaps the next call will work fine. So the overall SLA of that service would be better potentially when you use something like an orchestrator on top of existing services. So which one is better, choreography or orchestration? We've already mentioned some of the pros and cons, but well, the usual consultant answer is, well, it depends. So choreography is great when services are not closely related, totally independent, or if services can exist in different bounded contexts. So services being reused across different business processes. Perhaps for orchestration, if you are really able to define your business logic, your business processes in the shape of a flow chart, then you can use an orchestrator to describe that flow chart. But if in a big, loosely coupled environment, you don't always understand all the interactions that are possible through the emergent design and emergent behavior of the system of all the microservices interacting via eventing. Orchestration, if the services are not necessarily closely related, you can also reuse them easily with an orchestrator. And also, another question, if you want to stay with REST or not. But if you're happy with REST, orchestration is great. But it doesn't mean you can do choreography with REST either. But REST is great fit for the orchestration approach. And also, I'm not saying choose one or the other, but really you can also have hybrid approaches where you can combine them. You can have different orchestrated business processes, but have other parts of your system which are free floating messages on topics, on various eventing systems. Okay, so it's not one against the other, but it can be one with the other, and that's totally totally possible, and that totally makes sense. So sometimes if you go with the orchestration approach, you might continue to extend the system with choreography, loosely coupled microservices, event-driven microservices, and then fold those additional business processes as new workflow definitions, for example. So it's a totally valid way and totally valid approach that you may encounter in your own companies and customers. I'd like to say a few words about the landscape without necessarily diving very deep. In terms of choreography and event-driven approaches, there are, I mean, all the cloud providers provide different solutions for that. So on the Amazon Web Services side, you've got SQS, SNS, and EventBridge. With Azure, you're going to have EventGrid, EventHub, Service Bus. With Google Cloud, you have PubSub already for the message broker, and EventArc, also an eventing solution for some of our products. And also in the open source world, you have tons of solutions. So one of the most popular one might be Apache Kafka. Pulsar, also at the Apache Software Foundation, is also making some. I feel like it's becoming much more visible these days. So probably not as popular as Kafka, but Pulsar is very interesting and solves some of the shortcomings of Kafka. And well, many others. If you've used things like JMS, there are also classical JMS message brokers, etc. So you can use all those bricks, all those Lego pieces to build an event-driven solution for your business processes. In terms of orchestration, you also have Azure, AWS, and Google Cloud that provide different orchestration approaches. Step functions with AWS, and in particular with AWS Lambda. Azure, there's logic apps for that. With Google Cloud, I'm mentioning two products. Well, there are more actually, but there's Workflows, the one I'm going to use and present a little bit later on. There's also Cloud Composer. Cloud Composer, which is based on the open source Apache Airflow project. Cloud Composer is probably more for big data pipelines and not necessarily classical business logic of applications of business processes. But there are also other solutions. For example, if you're doing machine learning kind of pipelines and workflow, there's also Kubeflow that you can use on Kubernetes clusters. So it's not just for Google Cloud. It could be on any other Kubernetes cluster. What else? In the open source world, you're going to find Apache Airflow. And I don't mention the other commercial products, but in terms of orchestration, if you've gone through things like BPMN, BPL tools and notations and such, it was already about orchestration. Perhaps not about microservices in a serverless world kind of orchestration, but there are other products like Camunda. What else? There was another one that I had in mind. Another one that's famous. Well, never mind. I'll forget about the name. But there are existing orchestration products that are also available and potentially already used by your companies or customers. Another thing I'd like to mention, that's the serverless workflow specification, which is part of the. So there's a question. Shortcomings of Apache Kafka that make Pulsar a viable option. Yeah, so I've not dived very deep into the differences between Kafka and Pulsar, but Kafka clusters work with Zookeeper, and maintaining Zookeeper probably properly can also be a challenge at times. So I know that Pulsar is better in that regard, for example. What else? There was a great article recently on the Kafka versus Pulsar, and you might have to hunt down for this one to learn more about it, because I haven't really done my homework on this comparison. so I'm not really able to go deeper in those details. So be sure to check that, Karim. Yeah, back to serverless workflow specification. There's a project at the Cloud Native Foundation, the CNCF, for a new specification that defines a syntax, let's say a YAML syntax again, for defining workflows, for defining business processes. It's a declarative syntax, domain-specific in the sense that it's specific to workflow languages, to orchestrate events and services. What's interesting with that is that it's great to have a specification, because potentially at some point the various orchestration providers might implement that specification. On the other hand, the specification might not necessarily cover all the aspects of a particular product. So it's a bit like, think of it like a Venn diagram, where the specification covers some ground and the various products or projects might cover some other grounds and features, etc. And if you want true portability when you use a specification, you have to use the common ground between those various potatoes in the Venn diagram. Also, perhaps you're not using something like Open API specifications to describe your REST services, but serverless workflow specifications mandate the use of Open API to describe your API. So you might have to do some extra work if you want to describe all your microservices using Open API specifications. So it's interesting to follow what's going on. I've discussed with the product manager of Cloud Workflows that I'm going to tell you about this, and perhaps at some point, for example, Google Cloud Workflows might follow that specification. So we monitor what's going on around the specification to know what kind of level of support we can provide for such things. So I'll tell you a little bit about Cloud Workflow. So it's a new product that went GA in January. So it's a brand new product that is quite nice. And for a little side story, I'm also, although I'm part of the developer relations team at Google, which is part of the Google Cloud engineering team. You also get a chance sometimes to contribute to products if you have time and the desire to contribute. And I contributed 2 small changes to this product myself. So I'm a contributor to the product. So it makes me pretty happy. Yeah, so Cloud Workflows is an orchestrator which allows you to orchestrate various kind of services. So it can be serverless compute services that are hosted on Google Cloud, like Cloud Run, Google Cloud Functions, Google App Engine, or it could also be VMs on Compute Engine. You can also orchestrate Google APIs. Let's say you want to use, I don't know, machine learning APIs to do vision analysis and that kind of stuff. You can also orchestrate such calls to such APIs. But it works for any API, including third-party APIs or other cloud providers' API. So if I want to use SendGrid for sending emails, or if I want to use, I don't know, Stripe for payments, etc., I could orchestrate such services as well in business processes defined using Cloud Workflows. So with Cloud Workflows, you have a YAML definition file to describe your business process. So let's say, again, I'm going to use an example where I have a payment processor to authorize and charge credit cards, a shipper service that's going to prepare and ship items to your customers, and then a notifier service to notify users. So that's 3 steps. How do you define 3 steps? Then you're going to have 3 entries in your YAML definition file. So I have process payment, ship items, notify users. You can see how I can do an HTTP POST request to the URL of my service. I can also pass some body, some headers, etc., some body payloads. So the $curly brace notation, that's a way to reference other variables that are defined in this YAML file. Again, same thing here, the URL, post to the URL. Here, also notice that this first service was returning some result, the results of the call of that HTTP post. And the actual body of that response can also be passed as parameter, as an input to the next service. So here I can retrieve the body of that service. For example, I want to retrieve, let's say, the shipping address of the customer. Perhaps I'm going to retrieve that from the body of the previous service invocation. So it's a way of passing data between steps. And also, although we don't really see it in this example, but you can also access specific, you can go through the JSON payloads that was returned by this service and say, okay, process result dot body dot order dot customer dot shipping address, etc. So you can use a syntax to access the payload of the previous invocations. So what can you do? So you have step sequencing to define steps, like we saw. Oops. I'd like to hide this bar at the bottom. You can also introduce a pause. So for example, you know that some of the services will spend some time before being able to respond. So let's just wait for a minute. Yeah, I was mentioning the JSON parsing, so it's possible to parse the body of the previous request. You can also define the retry policy backoff. So for example, you want to retry 10 times, but the first time you're going to retry if the service failed. You're going to retry after 1 second, after 2 seconds, after 4 seconds, 8 seconds. You can define the multiplier for the backoff time. You can also handle exceptions. So if the service is not going to respond with a 200 status code, you can define different branches. So I can say, okay, if it's successful, I can notify the user and I can ship the customer. If there's a problem with the shipping service, perhaps I'm going to notify with a pager of some kind and escalate to support that there are errors with the shipping service, potentially. So you can also use a bit like try coach blocks in programming languages. You can define that and check the various error conditions in your workflow definitions. And speaking of that, so I'm reusing this logic for try catch when you see that there's not a 200 status code that is returned. And you can also have branches in your workflow to say, if something, then do something. So you can say, okay, if I'm out of stock, then I'm going to go to a particular step, the shipper step. If I'm out of, no, if I'm not out of stock, I'm going to call the shipper step. If I'm out of stock, I'm going to go to another step. So it's a bit like a go-to, if you want, to go to this other step to request the supplier to send me back some products in my inventory database, and that I have to update my inventory database with that. So you can have if, then, else, or switch blocks and conditions, go to one step to another depending on those conditions, and also do error handling. So you can have some complex logic in your workflow definitions. Some other features that I'd like to mention. There's sub workflows. So instead of having all the steps one after the other in your YAML definition file, you can also encapsulate common steps that you want, a set of steps that you want to reuse throughout your workflow. Let's say, for example, in one of my projects, I was updating some data in the Cloud Firestore database, a NoSQL database on Google Cloud. And I actually created a sub workflow just to do that part, like logging and saving some stuff. And it's great. It's kind of a function or subroutine if you want to modularize your workflow definition. And the other thing, I'm going to reply to the question. there's also connectors. Connectors when so it's a beta feature currently. There are some of the Google Cloud services or APIs that you can use directly using the REST syntax. Do a post request on this URL of the service, but there are also some specific connectors for Google Cloud services, which bring different advantages instead of calling them via REST calls. For example, you have sometimes long-running operations. For example, let's say if you want to use a speech-to-text API, a machine learning API, if you want to transcribe the text of a long speech, it can take perhaps half an hour to transcribe several hours of speech. So usually those APIs return an object saying, okay, we are processing your request, call us back to know more about the status. And you can do implement polling yourself to poll at a regular interval to check the status of an ongoing job. But if you are using connectors for those Google Cloud services, it's going to wait automatically for those long-running operations. So it can simplify your workflow. So there's a question. So as far as I can see, it would be possible to use an ESB solution like Talend or IBM Integration Bus on the cloud as our orchestrator. So yes, when I was mentioning that there are existing solutions for orchestrations, and typically Talend, there are ESB or IBM, or I was thinking also about my friends from MuleSoft, for example. They also have some great products there. So orchestration is not new. What's perhaps more not necessarily new, but those products were built in an era where you were building stuff on premises, on your own servers or on infrastructure, on data centers, whereas those new crops of cloud-ready orchestrators, they have been created for the purpose of serving Google cloud workloads. So yes, you can definitely use ESBs and such for doing orchestration. That's a totally valid use case, and you'll find the same concept as we're introducing here with workflows and cloud workflows kind of products. Yes, thank you, Edward. How do you handle workflows? So if you want to deploy, execute a workflow, see the result of a particular execution, so you can use the Google Cloud Console if you want to see things visually. But there's also the G-Cloud command line that you can use to deploy, execute, and check the executions of your workflow. So here are a few commands for handling, deploying workflows and such. And here is the UI if you use the Google Cloud Console. So you're going to see the workflow definition file in YAML. You can also use JSON. I'm showing only YAML, but most of our customers are using YAML usually. And what's great as well with the Cloud Console is that you can see a visualization of your workflow. So I was saying that when you have a flowchart, or whenever you can define your business processes in the form of a flowchart, cloud orchestrators are great for those kind of use cases. And what's nice with the UI is that automatically it's going to take your YAML definition file and produce a visualization, a flowchart of your YAML definition file. I'm not mentioning the other screen, but you can see the executions of your workflow. You can create new executions, etc. There are several screens. Perhaps I'll have some time to show you that when I'm going to do my little case study and demonstration. So speaking of which, let me tell you about an application that my colleague and I built, which is called, well, its nickname is Piccadilly. So it's a pun, play on words on the Piccadilly Circus, but it's a picture a day if you want. Piccadilly, it's a simple photo sharing application. We built it. So my colleague and I, Mete, we ran a workshop on the serverless technologies that are available on Google Cloud. And as part of this workshop, we created an application to show the various solutions that you can use on Google Cloud to deploy and create, develop an application using serverless technologies. And this is this photo sharing application that we built. So I have a screen there, which explains what it does. So it's a simple photo sharing application. You see the pictures that are shared and that are uploaded anonymously. You can see things like labels, which describe what is available in that picture. You can also see some colorful border around the pictures. And actually, for finding the main color, for finding the labels of what's inside the pictures, we actually use a machine learning service for that purpose, the Vision API on Google Cloud. And also, we also use that to check that anonymous users don't upload content that we shouldn't show on screen. Let's say porn or violent content and that kind of thing. And I think I have the application running here as well. So there's the main screen. There's a collage of the most recent pictures, and there's an upload screen where you can upload your pictures. So this is the application, and I can then choose a file, upload. What do I have? Let's say perhaps this picture. I can upload it. So it takes a bit of time for the various microservices to show to do their job, but after a few seconds, there should be the new service. Yeah, the new picture is there, the thumbnail service, etc. But I'm going to detail that application in a bit. Also, look at this URL, gco/codelab/serverless workshop. If ever you want to run that workshop and see how we build this application, feel free to check out this workshop. You can run it on your own if you want to dive deeper. So let me tell you about how this actual application works. So you've got end users that are going to go through the web front end, which is hosted on Google App Engine. The pictures are going to upload it into cloud storage buckets. There are two buckets, one for the high resolution, high definition pictures, and one for thumbnails. When a new picture, so this is the event-driven approach, the choreographed approach. When there's a new picture that arrives, it's going to call, or different services are going to be notified of that new file that appeared on Google Cloud Storage. So there's the image analysis cloud function. I'm using cloud function, whose job is going to call the Cloud Vision API to analyze the picture. We're going to store some metadata in a NoSQL database, serverless database called Cloud File Store. There's also the thumbnail service that's going to be invoked, that's going to create thumbnails of the big pictures. There's also a collage service that's going to be invoked on a schedule to create the collage of the thumbnails. And you also have another service that runs, so if you delete the big high resolution picture, we're going to do some cleanup, for example, remove the thumbnail and clean the data in the NoSQL database. So there's a kind of garbage collection service. That's why we call it image GC service. What else? What other events do we have? Yeah, that's about it. So we developed this application with services. So initially there was like just the image analysis function. Then we added the thumbnail service. Then later on we added the collage service. And then later on we added the garbage collection service. So we developed that in different batches of services. But so there are different ways to work with those eventing approaches. So for example, here it's a cloud function that receives events. Here it's a cloud run service for running containers in a serverless fashion that is using a different kind of eventing solution. And you also have this one. The last service here is using Event Arc, an eventing solution for Cloud Run and other Google Cloud services. And those three services use different eventing approaches. For example, this one that's with Cloud Functions. So you receive an event and a context for the event. For example, I'm going to check the name of the file that I received, the bucket where the file was stored. If you look at this one, that's the thumbnail service, for example, the messages are going through pub/sub topics. So I have to first receive since it's a Cloud Run service that receives HTTP requests, the pub/sub messages. No, let me backtrack again. You have notification messages for new files in a bucket, which are wrapped into a pub/sub message, which are then wrapped into an HTTP payload. So you have three levels of wrapping, well, two levels of wrapping of the original message. So you have to decode to receive the body of the HTTP call that wraps the pub/sub message, that wraps the encoded base64 encoded data payload of the pub/sub message. Well, you get the idea. So it's a different way of dealing with those similar events. And the third event, if you use Event Arc, which is a fairly recent eventing product as well on Google Cloud, it's again a different way to handle things because it's relying on the Cloud Events specification, which is also used in the Serverless Workflow specification, by the way. So it's using a different unmarshalling approach. So although these are the three same kind of events, the handling of those events is different compared to a REST approach where it's just REST calls where you handle HTTP requests. So instead, or especially, so there was the arrival of this new product, Cloud Workflows, and when we were developing this application, we noticed that it was complicated for us to figure out what was going wrong when one particular service was failing. So, or perhaps I would, well, the collage is not appearing, but why is it not appearing? Is it because the thumbnail service didn't have time to create the thumbnail first? So when you look at, you try to find some correlation in the logs, for example, but it might be more complicated because there's not necessarily like a global correlation ID. So I was looking for, in the logs, I was looking for things like the name of the file that was uploaded, the picture file, to see, okay, find all the logs that deal with that particular file and see if the failures are related to the same process, for example. So it can be, tricky and complicated. So instead, we decided to rewrite our application using an orchestration approach using Cloud Workflow. So if you look at this diagram, it looks more complicated than, well, perhaps more complicated than the previous diagram, but it's actually simpler in terms of the services that interact with each other, etc. But it's complicated in this diagram because I mixed two things: the flowchart, which is really those boxes there in bold, and the architecture diagram, which is made of those other rectangles. So it's a bit complicated because of that, but it doesn't mean that the actual architecture is complicated. So instead of the previous architecture, so we still have the web front end, we still upload files in Cloud Storage Bucket, but this time the events are actually going to trigger the execution of the workflow. And that's the workflow that is going to be responsible for calling the various services. So for example, we start the workflow depending on the various use cases. Is it because we deleted a high resolution file? Then we are going to go through that branch in the workflow. Otherwise, if it's a new file, I'm going to go into that branch. From the workflow definition, I can call other APIs like the Vision API. I still have I have a different function that does some data transformation that cannot be expressed in my workflow definition. But I've removed the previous vision analysis API that I had, the function that was dealing with this. So it's been made more declarative in this new architecture. The Vision API has done its job, and it can tell me if the picture is safe to display or not. So in that case, if it's safe to display, then I'm going to store the metadata in Firestore. But then I can call the thumbnail API and only call it if it's safe to display. Whereas perhaps before, perhaps the thumbnail was created even though I wouldn't show the picture in the web UI because it wasn't a safe picture to show. So I might have used too much computing, whereas here I'm really only calling the thumbnail and the collage services only if it's a safe picture I can display. And then that's the end of the workflow. So if, yeah, I'm going to show you that quickly here. So all the code of this application is also available on GitHub. So there's a repository. It's all open source. So feel free to look into how we develop things. But I wanted to show you. So let's say, or I'm going to show you the workflow UI instead, perhaps with an increased font size. So for example, let's say this part, for example, image analysis call. That's where I'm calling declaratively the Vision API to do machine learning vision analysis of the pictures. Or let's have a look at, for example, another part. So for example, storing the metadata about the picture in the NoSQL database in Firestore. I'm actually just going to make a REST call to the API of the serverless database instead. So I'm not doing it programmatically in my services. I'm doing it declaratively in my workflow definition. Same thing for the other services here, thumbnails, collage. It's just an API call to my services. And also notice things like auth, OpenID Connect, auth, OpenID Connect. It's because all the authentication is also done automatically. And I think, yeah, I have an example also where, let's say if something fails, I can also define a try and call and accept logic to do something if there was a failure in one of my services. And yeah, that's about it. And perhaps there's, where was my condition? Yeah, here, for example, when I check for safety, I have switch condition and I can check condition. So it's really at the workflow definition level that I can do that part of the logic. There are some extra. Yeah, so could you please copy the GitHub address in the chat? Of course, I can do that. So here, this is the workshop. So in the chat, I'm going to paste the link to the GitHub project. If you look at the description as well, the README file of this GitHub repository, you also find the links to the actual workshop. So there are 6 labs for the various services. So you can have a look at, if you want to redo the workshop yourself on your own, etc., you can go through the instructions. There's also a presentation that go through the description of the various pros and cons, the description of the products that are used, etc. And yeah, the architecture diagram. There are also shell scripts as well as Terraform scripts if you want to deploy that on your Google Cloud projects, and some extra links. So everything should be available from that link that I shared in the chat. And there was another question. Yeah, what about source control for tracking changes to the YAML code? So here, I'm showing you the UI of Google Cloud Workflows. But of course, this file doesn't have to be entered via the UI, via the Cloud Console. Instead, you can version it and put it into your GitHub repository in GitLab or wherever. And potentially, if you want to automate things a little bit, perhaps you could use, like, let's say, GitHub webhooks, and you notify that when there's a pull request with an update to the workflow YAML definition file, you could say, okay, I'm going to run some GitHub actions or some other automation CI/CD solutions, and then redeploy thanks to the gcloud commands used to deploy workflow definition file. So you could have some kind of automated approach to do CI/CD kind of automation. So this is a text file. It's a YAML file. You can put that in Git and version it the way you want, and then use CI/CD techniques to automatically deploy new versions of your workflows. So that was to answer Stefan's question. All right, let me switch back to the presentation mode here. So some of the lessons learned along the way. What was great when we developed the second version of our application using orchestration with cloud workflows is that it was a bit refreshing to use simple REST services and defining APIs rather than using the different eventing approaches and different eventing formats. I mean, there are good reasons why those different formats exist, but it's different ways of dealing with similar events, and that could feel a little bit wrong. So instead of using that, using a REST approach was nice and pretty refreshing. What was cool was that I should have highlighted that perhaps a little bit more in the two diagrams, but we had less code. We managed to get rid of like the garbage collection service, which was actually programmatically done and was calling two other services and APIs. I didn't really need that service. I could have described it because it was really, well, and I did it in the workflow definition, declaratively say, okay, this service is actually a call to other services. So I'm just going to do that declaratively in my YAML definition file. So there was also less setup. In the choreography approach and the event-driven approach, you have to use pub/sub and topics. So you have to configure pub/sub topics, the right service accounts to have access to the topics, etc. For one of the services, I was using scheduler, the scheduler to schedule calls to one of the services. And we were also, for the garbage collection service, we were also using EventArc, which is an eventing product, which is great, but still, we didn't have to do all that setup. The sole setup we had to do was the setup for using cloud workflows. And in terms of error handling, there's not that much error handling, but you saw a try except kind of block in my YAML definition file. It was easier in terms of error handling because I can just do that at the business process level in the YAML definition file instead of at each service level. So that was nice. In terms of the cons, so of course it's a new service, it's a new product, new syntax to learn. So there are things you have to learn along the way. There are some quirks. Also, in the first days, we were beta testers of the product. And when we were testing the product, in terms of documentation, it was a bit limited in the early days. So we had to figure things out. Now the documentation is better, but still, back in the day, the documentation was limited. Also, you have to be careful not to put too much logic in your YAML definition files because YAML is not a programming language. So what is real programming logic, be sure to keep that into services rather than in a big YAML definition file that could become unmanageable, hard to test, hard to debug. So be careful with that. What's real business logic? Well, if it's just orchestration of services, it's great. Use workflow definitions. If it's really logic with if then else and other kind of loops and whatnot, perhaps do that. Although you can do loops with workflow as well. Be careful not to overuse a workflow solution. And because otherwise it can also become hard to maintain. So the debugging, testing, logging approach, if you use the command line or if you use the Cloud Console, perhaps it's a bit painful because it's not like a programming language, so you don't have all the code completion and goodness that you can have in an IDE. Also, you may lose potentially some parallelism. For example, we were creating thumbnails and calling the image analysis function at the same time. So you weren't necessarily sure which service would finish before the other. So you may lose a bit of parallelism. On the other hand, the fact that we did things in a sequential fashion, we also allowed to, where we were able to say, okay, don't call this service if it's not needed. So loss of parallelism, but on the other hand, you may save on computing. Potential loss of eventing flexibility in the sense that if you have to add a new service in the business process, it's not as simple as just receiving an existing event or adding a new topic. So you have to redeploy the workflow and check that the overall business process works compared to an emergent behavior of a loosely coupled approach. So that's about it. Any ways to, another great question, any ways to use it on premise? That's a great question. Currently, Workflows is it's a cloud product, part of the existing cloud products of the Google Cloud Platform. So currently, no, you cannot use it on premises. We're thinking about it. So whether to do an open source version or at least being able to import and export existing workflow definition formats, perhaps serverless workflow definition files, perhaps some other common kind of notation. So it's still up in the air. I don't yet have a good answer to that question, but currently it's no, you cannot use it on premise. And yeah, no more questions. So yeah, here are some links to cloud workflows. I have some articles here about workflow tips, some quick starts if you want to get started. And we also have a code lab if you want to get your hands on cloud workflows. Woohoo! A bit more than an hour, but yeah.
Thanks a lot, Guillaume.
Thank you.
Do you want maybe to tell again for the French speakers about your podcast?
Oui, you can, well, I'll say it in English perhaps. So there's a Les Cast Codeurs podcast. Do I have a URL handy? Well, just search for Cast Coder and you'll find that easily. Yeah, can listen. And I couldn't join the recording of the latest episode because it was during the Malt Academy.
Oh,
but it's okay.
We are very happy to have you here today. Thanks a lot, Guillaume. It's been pretty intense. I see that you had a few good questions. Thanks everybody for following this Malt Academy. Thank you for your questions indeed. And I'm just going to send you a little CTA in case you want to see what other Malt Academies we are organizing with other great people, maybe as great as Guillaume, maybe not. I won't tell. Thanks again. And yes, have a nice day, everybody. Take care of yourself. And see you soon, I hope, on another Malt Academy. Thank you, Guillaume.
See you. Have a great day and great weekend. Bye-bye.